All right. We want to talk about some probability rules. Rule number one, the probability P of A, and that's our notation that we want to get comfortable with, is this probability of A happening, satisfies that 0 is less than or equal to P of A is less than or equal to 1. So all probabilities are between 0 and 1. So we write them as a decimal, okay? Dot P of A. Okay, a decimal between 0 and 1. We don't, in AP Stats, write them as percents very often. We write them as decimals between 0 and 1. The sample space in a probability model, if S is the sample space, the probability of the whole sample space is 1, right? If it's all possible outcomes, then you add up the probabilities of each of those outcomes. It had better add up to 100%. That's why a density curve works great, because a density curve has an area of 1, okay? And the area under the curve is the probability associated with it, okay? Two events are disjoint or mutually exclusive. So disjoint means they're not joined together, okay? Or mutually exclusive. So if I'm in group A and I'm excluding you from my group. So you're group B, I'm excluding you from my group, but it's mutual. You're in group B and you're mutually excluding me from your group if they have no outcomes in common. So this is like a Venn diagram where they don't have any overlap. So they can never occur simultaneously. So if I want to say what's the probability of being in A or B, I can just add them because there's nothing that I would need to subtract that's in the overlap. Okay, that's the addition rule for disjoint events. We'll have a more general one where you subtract the overlap in case they're not disjoint. But the overlap is 0 for disjoint events, so we don't have to subtract anything. And then the complement of any event is that the event A does not occur. You can write it as A to the C. I also write it like this, tilde A, not A. That's the logic way of writing it, the complement of A. You can write it like that, and it's 1 minus the probability of A happening. So here's a sample space of all possible die rolls. So notice a red 1 with a green 2 is different than a green 1 with a red 2. They're two separate events, okay? So what's the probability of doubles? And these we're assuming are all equally likely outcomes. And so there's 6 by 6 is 36 outcomes. And we have 1, 2, 3, 4, 5, 6 doubles out of 36, which equals about 0.17, okay? Probability of not 5, or I could write it as probability of 5 complement. Okay, so the 5s are 1, 2, 3, 4. So it's 1 minus 4 out of 36, which ends up being 1 minus 1/9. So we end up with 8/9, which is 0.8 repeating. So we'll call it 0.89. It's the probability of that. Probability of doubles or 7. So first of all, are these mutually exclusive? Well, here's all my doubles. Do any of my doubles, here I'll highlight instead, do any of my doubles add up to 7? No, they're all going to be even numbers. Where are all my 7s? So 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since they're mutually exclusive, we can say P of doubles plus P of 7, which is 6 out of 36 plus 6 out of 36, which ends up being 12 out of 36, or 1/3, and we get about 0.33. Okay, so complement, mutually exclusive, and just the general rule: probabilities are between 0 and 1, and they add up to exactly 1. Cool. Good luck. Farewell.